Good afternoon, everyone. So my name is Libby Larson, and I am the coordinator for the North American Carbon Program, which is a community of practice of researchers who are studying the carbon cycle in North America, sources and sinks and adjacent oceans, lateral transfers, all that kind of really exciting stuff. And within the NACP, there is a subgroup that Gami is currently the chair of, and although I think she's also looking for perhaps some co-chairship assistance in that. And that working group then is focused on CDR, and I guess we're expanding to think more broadly about greenhouse gas removal in general. And this group has met a few times. We are aiming to meet quarterly, and there's been mostly an interest of just trying to get to know what everybody's working on. It's a pretty exciting group from my perspective because there's been a lot of participation across from both the sort of more research side and academia to some more private sector and applications, and of course the federal realm as well, thinking about governance and regulation, which I think is especially needed in this arena. So I would say that the group is a little bit still nascent in figuring out exactly what it is that we can all do together, although everyone is excited to do something. And along those lines, Cami and I are in the process of finalizing a very short survey that we're going to send out to the list that just asks about your affiliation and your particular interest in this realm, and if you're interested in collaborating or finding connections with other people to sort of describe that a little bit. So I think that it will be a really great thing going forward for us to be able to keep in touch. And I know that Gami is also interested in, potentially organizing other speakers at later meetings as well. So if you are especially excited to share about the work that you're doing, I think that please feel free to reach out to Gami. And so we will, Gami, why don't you put your email in the chat? And the first speaker that we have today is Pam Chu, who is from NIST. And she will be talking about the CDR consortium that NIST recently put out a Federal Register notice for. And after her very short description of that and what's going to happen with that, I'm assuming that Pam, you're open to taking questions from the group about any thing that they might have about that. We then also have a presentation from Adam Wolf, and so please be sure to stick on the line. For everybody who is just now joining us, we are recording this presentation. After it is done, it might take a few days or a week or so, but we will be posting it to the NACP website. And when it's ready, I will be sure to notify everybody that that is accessible and can be shared. Oh, somebody is not muted. There we go. Okay. Cami, do you have anything else to add as an introductory remark for this?
No, that was great, Libby. Hi, everyone. I'm Gami Shrestha, and I've been chairing this small work group for a while now, and I'm grateful for Libby Larson, who leads the NACP, for offering this platform for all of us to get together. And I think with this, we should just, kickstart these presentations and conversations. And thanks everyone again for joining us today.
Okay, so Pam, I'm going to turn it over to you, and I'm going to turn.
Okay, great, thanks. So I think everyone hopefully has seen Gami was very generous and passed her email around about the new NIST consortium that we're standing up for carbon dioxide removal. So essentially, one of the challenges with all these different things that we're facing is that there are measurements that are needed to help underpin and better understand the different processes on how we're removing, well, one, the carbon cycle, two, how we're removing carbon dioxide and how much are we removing. And since there are many different pathways, getting a good understanding both within a pathway, how are we quantifying things, and can we make good comparisons across one given pathway, as well as across the different pathways. There's a lot of challenges of making sure that we're quantifying this correctly, so that as things are, one, traded, carbon credits are traded, and two, as carbon footprints on different products are assigned, that we have good quantitative data behind that, all as best the best quantitative data that we can reasonably provide, because as everyone knows, this is really quite challenging. So to that end, NIST has started this consortium. We welcome all participants. Basically, the process, I thought briefly to describe the process, how we start this up is really we have folks send in a letter of interest to NIST at CO2 removal at NIST.com. Gammy, maybe you can put that in the chat for us. And then what we do is we'll be looking at we'll be reviewing the letters of interest, and then working with those folks who submitted the letters to actually sign a cooperative research agreement. This is a requirement for folks to join the consortium. If you're part of a federal lab, an actual government lab, there is a different approach. We usually have a memorandum of understanding. So that's the process. We are, because there's so many different pathways, we are focusing for the moment on forests and direct air capture. So we are covering kind of the two ends of the spectrum of as far as engineered enclosed systems to open systems. One, of course, is scalable now, whereas the other is there's a lot of technology that needs to be developed to really have it at a climate impactful scale. So I think with that, I really I just want to introduce the concept and open it up really for questions. I will have to say there's also an information session that we're going to have on September 12th. I believe it's at 1 p.m. And you're welcome to send us an email, again, at co2removal@nist.gov if you want to join that info session. That'll be a virtual info session. Okay, so there is a hand raised already in the chat. Why don't you just go ahead? Toby?
Yep. Hey, thank you, Pam. Yeah, my question is, and first of all, thank you for organizing all this. It's really, I think, seems really important and much needed. Can you talk a little bit about the cadence of convening that the consortium will have, and also what if folks are selected to participate, what the kind of input that would be expected would be? And I asked, I'm at Yale Center for Natural Carbon Capture, and a number of our scientists are interested, and they just want to understand what would be required of them if they were to participate or be selected to participate?
Right. So that's, of course, a great question. And part of it is we want to bring folks on board and understand kind of what they think would be useful. The goal, the structure of the consortium would be, we would have every organization can have a member on the steering group. So you can have the steering group would provide some guidance in general, and we'll have a charter. Then we're anticipating working groups. Naturally, it's anticipated we'd have one in forest and then one in direct air capture. And then I could see that since there are so many other pathways, maybe there'd be other people that would want to join that are involved in the other pathways. And maybe it's more of a little bit of an overarch. It looks at some of the overarching issues. As far as the cadence, we have another consortium going where the working groups are meeting essentially every other month, with some, ideally we have participation from those members, and we end up developing some writing assignments and recruit folks to help contribute to all of that. This is a all hands in effort, and we do need participation from all to make this successful.
That's super helpful. Just one quick follow-up. On the other example out there of a working group, the bi-monthly meetings, are they virtual, and like how long are the meetings?
So that's a great question. So they have been virtual, and what we've done is once a year we've gotten together in person. What we do think that we might do for this kickoff is to actually try and have some in-person meeting, and maybe it's more a little bit more targeted with you know, like on the forest side of you know, other forest related meetings, and you know, on the DAC side, DAC related meetings, so that people don't have to add more travel. So maybe it would be adjacent to those sorts of meetings. That's the concept. I personally think if we can start off with an in-person meeting, that's going to build the team a lot faster and will be a little bit more productive. And so that's a goal. But you know, even just the process of folks signing the CRADAs and making sure that we actually have, you know, a sufficient representation of where we're going, it's going to take at least another 6 to 8 weeks is my anticipation right now.
Thank you very much.
Yep. You're welcome. Maureen.
Maureen.
I actually recognize some people here. This is exciting.
Hi, Pam. Quick question. What do you see as the outcomes of this working group and of the consortium? And is it directly related to NIST, or is it supporting other agency directives?
So we're really trying to build consensus across the communities of the different approaches and standards that folks are working on. There's, as you might know, a lot of folks are working in a lot of different areas with a lot of standards development is happening, and you know, that's great. But one of the challenges that we're seeing is that standards are there are a lot of standards. And that makes it really, really difficult. So trying to look at all the different work items that have been created already and see if we can build some consensus is one thing that we do want to do. Another thing that we want to do is understand what the state of the measurements are today and how we might need to advance them to make them faster, better, more effective, cover more areas, things like that, which, you know, is something, of course, is near and dear to this perspective, because the measurement technology development is something that overall we're interested in, and also to understand whether there are standard reference materials that are needed to also help underpin and build that quality infrastructure for the measurements. Those are the things that we're interested in. You know, I think in general, this, you know, falls in line with what this mission is to help bring together, build the consensus in the standards area. And I think overall, there are a lot of benefits across the whole ecosystem, quite frankly, to have this effort going on. Of course, I'm a bit biased. Of course, I have to say that about a program I'm standing up. But you know, I hope people are going to see some benefit. It's you know, the standards work is difficult. It's challenging, but I think there's a lot of reasons to move forward with this. Yep. Any other questions? Great. Well, I hope to see lots more emails in the CO2 removal at NIST.gov.
So one more quick question, Pam.
Sure.
You said you were focused on forests and direct capture. Is there an intention that this would move on to other ecosystem types?
Very definitely. The challenge for us is we just have limited resources, and so you know, we're trying to address the needs as best we can, and we felt like staying focused was the best approach for us.
Hey Pam, I think there was another question from another person here. They want to go, and then I'll hold my question for after that.
Right. I did see a hand flash up, but maybe it was comparable to what Maureen just asked.
Sorry, that was me, but Maureen actually asked the question. So just a sense on the timing of addition, I understand completely kind of picking, can I just add a little bit more clarity? DAC and reforestation are like kind of ends of the spectrum. Is that the thinking, that you're going to get these two ends and then you kind of work yourself in, because there are a lot of other methods that involve nature and technology. And is that how you're thinking about it?
I don't know that we were quite that strategic with the approach. I will have to say from our end, NIST has an effort developing, looking at benchmark materials, DAC sorbent benchmark materials. And so we were coming at it from that end, of leveraging kind of what NIST is already doing in that space. And then we had some customers that really felt that the forests were a good area to start with because of because it is scalable. It's the nature-based system that there's a lot of questions there. I think where they're eager, and lots of carbon credits are being purchased already in that space. So I think they were eager to get us involved in that.
Hey, Pam,
Yep, sorry.
Very quick question. So I think you already answered this earlier, but the CRADA, would it be in the organizations or can it be individuals and NIST? How does that work?
So it is organizations with NIST, and then you have the different individuals that will participate in the consortium activity listed within the CRADA. So it is the organization with NIST.
Okay. And the other question is the other group that's been meeting bi-monthly, what is it called? And what's its relation to this new consortium?
So the other consortium, so there are many NIST consortia.
Mm-hmm.
The other one that I'm working with is the low carbon cements and concrete.
Got it. That I know.
So, yep.
And it's going to be working with this new consortium in some ways.
I think they're different enough and independent enough that we probably, I think we're making each consortium membership aware of the different activities, but I think they're different enough that we're not going to combine calendars and things like that. The cement consortium has been going on for over almost 2 years, or approximately 2 years at this point. So
that's great. Thank you, Pam.
Yep, you're welcome. And I'm happy to answer any questions if they pop up. Feel free to email us. I think it's really best to email us at co2removal@nist.gov.
One quick question, Pam. In forest, Are you including everything in the forest, or is this, all the biomass? So soils, understory, everything like that. Is that included in your?
That's a great question, Maureen, and quite frankly, I don't know just yet. Sorry, I don't have a good answer for you.
Yes, please.
Yeah,
it was something that we identified in the Soccer 2 report, that we really need to be inclusive of the entirety of the ecosystem when we look at them. So we would encourage that. Gammy?
So
Yeah.
I suggest you join in and voice those opinions, and we'll have it all covered then.
Yeah, and I would say, how about agroforestry and all these other associated sectors, and also Pam, how about the other agencies and departments? How are they going to be involved in this?
Well, ideally, we have all the other agencies involved. That's a bit of a process, but ideally, we have all of them involved. So it's across government, across the private sector. So it's it's a big tent. That's the goal.
So have you already reached out, or do you want people to reach out to you who are from these agencies or different other entities that should be involved?
So feel free to spread the word. We do have a nice list of folks that have inquired and are joining our September 12th meeting. A wide variety. I think of the other agencies, EPA was the largest one that we've heard from so far. But it's just recently come out, and with vacation and everything, I think it's going to take some time to really get the word out.
Great, thank you, Pam.
Great. Oh, and we do have DOE. So yes,
it's great. Well, thanks for joining us. I know, Pam, you're very busy right now. You're about to travel, so really appreciate you joining us. And
Yep.
And hopefully, I think this will not be the last interaction with you and this group.
And we can give reports to this group too for those, you know, periodic reports, and that would be fine.
Thanks, Pam.
Great. Take care.
Right. Take care. All right. So next in our agenda, we have Dr. Adam Wolf from ION and also the Enhanced Rock Weathering Coalition. So please, Adam, deliver your presentation, and then you can take questions after that. Again, thanks for joining us.
Excellent. I appreciate the invitation. Let me share my window. And I will put us into slideshow mode. You can see this okay? Can I have a verbal yes? Yes.
Yes,
Okay.
looks
Looks
good.
good.
So my name's Adam Wolf. I founded a company called ION, but in part because we knocked on so many doors that had never heard of enhanced weathering, a group of us decided to form an industry association, the Enhanced Weathering Alliance, in part to give talks like this, so more people know about enhanced weathering and are aware of the particular questions that we're asking. And here, my goal is really two things. One is from an interagency perspective for the folks that are coming from different agencies to know where we'd love for you to plug in. But also from the perspective of those science questions, there's some very targeted areas of collaboration that I'd love to promote. So just want to have a quick orientation on enhanced weathering so that we all get to the same page to outline just kind of the breadth of activity that's happening right now in this field. And then really the ending is on what are the key questions and how can agencies help. So as a quick orientation, why do we love enhanced weathering? It fits this sweet spot for being low cost and abundant at scale. So it has this kind of scalability attribute of what we just talked about, forests, nature-based systems. But it also has the permanence that we associate with direct air capture. And so we see it as something that can sort of meet the best of both worlds. It also has this key attribute of having co-benefits, chiefly within the agricultural sector, that itself is kind of a scientific question to run down the agronomics. How does it work? It's kind of simple. The rocks are quarried or pulverized. In many cases, people are using waste fines. In our case, we directly pulverize the olivine that we use. So there's a lot of different exploration of the feedstocks. These are applied to soils. If you work with plants, plants take up CO2 from the atmosphere. They also respire a lot of CO2. A lot of that's underground. And it generates the reagents that are being captured, but it also generates the acidity that weathers the rock. And so part of that acidity is being mitigated by the weathering of the rock itself. So that's fortuitous. The reaction products flow into the freshwater system, into the groundwater, into the rivers that flow to the sea. There's an immediate loss of CO2 as the freshwater meets the ocean. But then ultimately it's thought that the dissolved inorganic carbon remains in the ocean on timescales of 100,000 years or more. So this is just kind of a cartoon version of that, where we're adding these magnesium silicates, they're dissolving, they're entraining dissolved inorganic carbon into solution. They are flowing through the system out of the root zone. and ending up in the ocean. And you could picture that the MRV challenges, the measurement challenges, are understanding what box are we in, right? Have we put rocks in the field? Have the rocks dissolved? Have the rocks reaction products leached out of the system? And what happens when they reach the ocean? So the process is quite simple, and because of that, a lot of different people, individuals, myself, and other entities have gotten excited about bringing it over the line, where even as recently as a couple of years ago, there really wasn't hardly any activity to speak of. And so in the middle, point to here, rural lands, there's landowners, there's farmers, there's forest managers. This is where all of this carbon dioxide removal takes place, and they're obviously an essential stakeholder to this. There's a number of us that are project developers, and it ranges from, some of these have 2 employees, and some of these are multinational corporations. And so it ranges a wide degree of what kind of expertise and experience they're bringing into play, especially those strategic partners that can work at scale. And this is balanced on the one hand by civil society groups, so friends at EDF, Nature Conservancy, and Carbon Plan that are making sure that we are staying within the guardrails of, safe deployment. And then there's industry groups, of which we are one, advocating for the advancement of CDR generally. And then there's, I'll show you in a couple slides, a massive number of academics and institutions working on this. Now, there's also an entire commercial ecosystem. So there's catalytic buyers, of which there's a relatively small number. There's various marketplaces that connect with small and middle-sized institutions. And there's enablers like finance and digital platforms for keeping track of all the data. But what's striking to me is to look at the rate of publication that is coming out of enhanced weathering. And so you see an exponential growth of new authors who are producing papers. And that's generating a massive number of new publications. I made this, I think, in April, and we've continued to see a large output come out. And this is kind of spread between, private institutions, land grant institutions, federal institutions. And really, one of the things that I'd like to see more of is ag schools, land grant schools, being able to do this work, particularly in the Mid-South, the Southeast, where enhanced weathering has the greatest kind of potential from a land perspective. I also want to highlight that there's been a lot of federal support, and this is quite distinct from other countries, and in particular in Europe. So there's a lot of different programs from the DOE that are supporting enhanced weathering. The marquee version of this is the carbon negative shot, which we anticipate the announcement to come out before too long. The purchase prize is also prominent. But then there's a lot of other areas, for example, the LCA voucher program supporting the MRV. And then there's a lot of outreach to how we can implement this in policies that are under discussion. Pam referenced accounting for the carbon intensity of products. That's a core part of the Prove It Act. And so I want us to see that the work we're doing with federal agencies is really informing how best to implement policy and lead to the economic well-being of producers and people who process farm goods. So I don't want to go too deep here because it's a rabbit hole, but I want to highlight to you, I know there's a lot of technical people on the call, what are the key questions and how agencies can help. So these are kind of the hot topics in enhanced weathering science right now. And it includes, what really are the mineral resources available to this? How do we account for the life cycle of the emissions stages? There's a lot of questions connecting mineral resources to what, lands they should be deployed to. And then deep in here, we're kind of down at the sub-meter scale to understand the weather drivers, the plant drivers. These soil boundary conditions are particularly important. Modeling frameworks, there's a big gulf between folks that are working on land surface models that are hydrology and carbon cycle heavy. And then there's a whole isolated and separate community of people using reactive transport models that are very deep in chemistry and have virtually no hydrology or vegetation representation. And so we're bridging some of these cultural divides within the scientific community. Tracking the fate of dissolved cations. So USGS plays a key role in monitoring groundwater and rivers, but then in the ocean, NOAA has all the carbonate chemistry data. DOE does a lot of groundwater modeling. Within the health and safety arena, trace metals are a very key question. So these ultramafic and mafic rocks have trace elements that have never really been studied closely from the perspective of agricultural applications. And so none of the existing regulatory work or health and safety assays is quite a good fit. And so you see a lot of agencies that are have a footprint in this. And then of course, there's a bunch of co-benefits that are digging into agronomic value and opportunistically the nitrous oxide emissions, which of course is the largest greenhouse gas emitter in agriculture, and we have the potential to address that. And so again, I'm not going to go over each question, but I want you to see that there's areas where the expertise in this room, or maybe your colleagues, can be helping investigate it, and we need help. And then it's very timely for me to follow up after Pam. There are many different agencies and then subgroups within the agencies that are wrestling with MRV. So this isn't really the science. This is like operationally, how do you report what you measured such that it can be verified? And so the DOE had a call for national labs to work on MRV for mineralization. NIST, of course, just announced the CDR consortium, but again, focused on forests and DAC. The DOE had a great workshop a couple weeks ago for LCA reporting under the utilization clause. You could picture that as a lime substitute. The carbon that we're removing is being utilized for soil pH management. A lot of this reporting applies. And again, this is like how you report your taxes. So it's highly tactical. It's not science. The USDA is engaged with how MRV might work for biofuels. And there's a lot of activity related to biofuels, in particular, how it might be implemented within GREET, how it might leverage different USDA conservation practices. This had on the order of 50 different members of Congress sign on to it. So there's a lot of interest here. from Congress to get the Treasury to develop guidance. So some of the questions again here are around like amortization, how to account for byproducts, how do we treat removals and reductions differently, the existing approaches for MRV. If like I'm a project developer for a forest or a DAC plant, I don't need to do bootstrapping based uncertainty, but we do that in enhanced weathering. And so I want to just kind of highlight some of the unique questions that are showing up here, and those feed back into how do we actually finance projects and what the role of the federal government and what a paper practice or federal procurement scheme might look like. So I think I kept it within the time frame, but I recognize that I went very quickly. And I would love to get just kind of a read from the group of what your questions are as far as how to get engaged and how we might fruitfully follow up, because there's a lot of scientists in our industry that would love to collaborate with you.
Thank you, Adam. This was a very good summary and overview, and very relevant to everything that's happening now in this space. And I think so if you have questions for Adam, please raise your hand and speak up. And I guess, Greg, did you have a question?
Yeah, thanks for the nice overview. You hear me?
Barely.
I can crank. Yeah, thanks for the nice overview of I guess my question is, as you
Greg, I'm sorry, it's really, really hard to hear you at all. I don't know if you have a mic or if not, you can type it in the chat and maybe one of us can read it out to Adam.
okay, I'll work on my audio and ask a question if
I can barely hear you, and if you say your question, I will repeat it to the group and then answer it.
Okay, well, my question is, rock weathering isn't necessarily confined to the terrestrial environment. So to what extent are you extending an invitation to those of us working in the marine environment looking at enhanced rock weathering?
So the question is, I gave a terrestrially biased presentation, and Greg's question was when we might extend an invitation to the marine enhanced weathering community. And we have been asked this question before, and we ask it among ourselves, you know, what are the boundaries for this group? And the stakeholders involved in the terrestrial environment, particularly agriculture, is very distinct. And I see one of our jobs is leveraging these stakeholders to be active and advocating for things that they find valuable, for example, to their members of Congress. And I see that the marine environment has a totally different group of stakeholders, both proponents and detractors. We have our own proponents. We also have our own detractors. And given that the constituencies are so distinct, we've tended to see that as an industry group, it makes sense for us each to have a separate entity. But like many of the learnings from the marine enhanced weathering are valuable to us, in particular, how to engage on health and safety to have a proactive discussion with concerned citizens.
Thank you. I would just add that regardless of whether or not you include us or not, we do have a common MRV issue because your carbon winds up in the ocean as does ours. And so certainly that is an area where we could collaborate in looking at the fate of the carbon that we ultimately.
Absolutely. So one of the areas that I wanted to explore, so the number one loss term to the atmosphere in terrestrially enhanced weathering, it's not grinding, it's not truck driving, it's not extraction, it's the loss that happens when fresh water goes to the ocean. So for olivine, about approximately 1,000 kilograms are removed by the rock. About 30 are emitted in the transportation, about 30 in the pulverizing, about 2 in the extraction, and 150 are lost once this water meets the ocean. And so that's like the biggest economic driver if you look at it. And it's very poorly constrained, the carbonate system in estuaries meeting the ocean. And it needs the power of supercomputers that honestly we don't have access to. We don't have access even to a coder who knows how to like set up a run on a supercomputer. And so I've spent a little bit of time engaging with groups like Seaworthy to see, well, how can we use some of those same resources that are like very strongly shaping the due diligence process of marine CDR, like will it work or not work? Well, all of that modeling framework should be able to inform, you know, I'm working in a river that's draining into the Gulf of Mexico. Is that different than if I was working on the Columbia River? Can I take a discount that's different if I'm working on a better river? And those can and should shape the economics of projects to make some, you know, undesirable and to make some more desirable. And so I agree. That is like a really valuable engagement, and I'd love to strategize with you how we can unlock some of that talent, honestly.
Thank you.
That was a really good question. Other questions? So Adam, you mentioned something about the power of supercomputers and all that. Is there anything going on, or you could elaborate more on maybe AI or data science related, I guess, tools that are being used that could be used for this?
Yeah, so it's interesting. The Department of Energy has been the most clear on what they're looking for from enhanced weathering project developers, as like what they see are the key questions. And one of those that comes up over and over again is a first principles process-based model of the CO2 budget. And this is in part to drive, you know, sensitivity studies and, you know, cost reduction projections and things like this. Now, there is, I come out of a world that is mostly driven by land surface models that are working at climate scale. And these have like very sophisticated representation of hydrology and like latent energy. And so they're conserving mass and energy at, you know, whatever scale that they're working at. Interestingly, the vegetation, it's sophisticated in terms of the numerics, but it doesn't really represent agriculture as it's practiced. So then like the Century model or Descent is most commonly used for something like the USDA for carbon cycle modeling. But as far as I know, it has like no mass balance for water energy. And then we have models like Freaksy or CrunchFlow that have like exceptionally sophisticated reactive transport for like, I don't know, will secondary silicate minerals form from the reaction products of these? Or, you know, how much of the reaction products will get stuck on the exchange complex? So they're treating the complexities of the chemistry, and yet they are not suited to fit inside of a climate scale model. And for better or for worse, the core questions are at the intersection of these three types of models. And I think the carbon cycle, like in terms of crop planting, isn't necessarily the most important for understanding our science questions, but it's essential to envision like those models, those land surface models, having some of the core carbonate system dynamics that we think are important. And so I would love for something like the CLM or the community eco or system model to be able to incorporate some of the core like chemistry that we care about. And then we have to have a discussion of, well, what do you think is important to port over from the like the intensive reactive transport models to the larger scale climate models? And Toby highlighted a project that I think was funded by, was that funded by DOE or funded by Google? That was kind of a modeling heavy, like how do you model such a large system? Because we're working at different scales with different observations to falsify them. And so one of the reasons why I quit academia, to be honest, was that there is a massive amount of modeling with a relative paucity of observations to falsify those models. And so a lot of what we do in the climate science community is project like, what will my model parameterization do to change the climate in 2100? And enhanced weathering, for better for worse, suffers from some of the same issues where the amount of modeling far exceeds the amount of like direct observation. And this is an area where I really want to have great great collaborations between the empirical side and the modeling side, because project developers like coming from industry are probably default way more towards the empirical side. And obviously when we're talking to folks like yourselves, you are the ones who developed all those models. And so I think it has the areas of a fruitful collaboration. What was Chris's question? A good read on the range of proportion of olivine fixed carbon that is lost to carbonate chemistry. It's 10.5%. So the total amount of loss is approximately, it's less than, but nominally 1% is lost to the plant uptake of cations. About 2% is lost to charge neutralization with strong acids like nitrate instead of with bicarbonate. Another percent, again, it's far less than this, but putting an upper bound, a percent for riverine carbonate precipitation, which loses a CO2 when it precipitates, and then 10.5% when the water drains into the ocean. You know, depends on the local carbonate system chemistry, but in general, around 14% of the removed carbon is lost to this downstream system losses.
Yeah, I mean, I'm a total non-expert and I'm really curious to learn more, and I'm loving hearing about this. I'm just wondering how variable that is. That sounds like a very precise estimation of something that could be highly variable in a whole range of real-world environmental conditions.
Well, definitely. And what Greg's question was like, what about the marine side? How can they help? They might make the difference between like, is it 9%? Is it 11%? And some of that in turn depends on the representation of the model, like how quickly does a water parcel submerge and become isolated from the atmosphere. And, you know, that in turn requires like fairly resolved models to capture this kind of bathymetry. And so it's outside of my realm of expertise, even though I'm sensitive to the problem. On some of the other ones that are happening in the soils, like do carbonates form? That's kind of local to the soil. Like if you're in some parts of the US, there's subsurface carbonates. The strong acid effect varies. It's been shown to vary widely depending on fertilization rates. And so where you have a lot of fertilization, it's more of a problem. And then, you know, if we're applying in pastures that are starved of fertility, well, then maybe it's more efficient. And then the riverine, I would not do a service. Many of my colleagues that are focused on the riverine, you know, export and the river carbonate system, the USGS, I think, is like shut down a lot of the funding that has gone into measuring river chemistry. And so it's one of the great like data assets of like living and working in America is the USGS river chemistry. And it's like essentially we get to work with historical data at this point. But there's a lot of super interesting stuff happening in what's being called the near field zone, the soil zone, as relates to these losses. And I'd love to, like from an economic perspective, use this in a way to reward doing this where it's the most effective. I didn't answer AI though. There are some very killer data sets that relate to both the soil and the river that are, you know, massive and merit mining through AI in particular, because a lot of the KPIs we're after, like me, I'm interested in like the magnesium in the soil speciated by what minerals that are, you know, soluble under different acidities, you know. And so it's subtle. I can collect some of that data, but then the soil survey has collected a lot of soil information, digested in different ways, and be able to understand that question. And so how best to unlock that data is a key question.
Well, thank you so much, Adam. We're at the top of the hour. We have 3 minutes left. Does anyone have a question that they absolutely must ask? Pick up. We have 5 seconds. We'll wait 5 seconds. Otherwise, we'll wrap up.
I will send you the presentation. You can distribute to the participants.
Sure. Please send it to Libby and I, and then Libby can send it out. Thank you so much, Adam. This is super informative. And thanks for this audience and the participants. Very, very interactive. And thanks so much for being part of this. Libby, do you have any final words?
No, just thanks again to everybody, and we'll be in touch. If you got the invitation to this email, you're on our list, and so you should be receiving updates from us about more activities to come.
With this, let's adjourn. Thank you.